Hello everyone, welcome to your physics class of Wavelength. I hope you all will be fine. Students, in my previous video I explained you that sounds needs a medium for propagation and also sound travels in air in the form of longitudinal waves. Now today in this video we will discuss about the terms related to a wave. Okay, first one is one vibration. The to and fro motion which constitutes one full wave is called one vibration. Okay, that is in figure 6.19. You can see in figure 6.19 one wave is from one rarefaction to another rarefaction or from one compression to one compression. Okay, so one vibration is the to and fro motion which constitute one full wave is called one vibration. Now second is wavelength. The length of a wave corresponding to one vibration is known as its wavelength. Okay, and it is represented by lambda. Amplitude. The maximum displacement of a wave on either side of its mean position is known as amplitude. Okay, then time period. The time taken by a wave to complete one vibration is known as its time period, and it is denoted by capital T. Frequency is the number of vibrations produced by a source of sound in 1 second. Okay, and it is denoted by F or N, and its unit is hertz. So these are the terms that are related to wave. Now, audible sound. Audible sound is of the frequency 20 hertz to 20,000 hertz. Okay, and we cannot hear sounds of all frequencies. We can hear sounds of frequencies in the range from 20 hertz to 20,000 hertz, and we cannot hear below 20 hertz and above 20,000 hertz. So this is the frequency, the range of frequency from 20 hertz to 20,000 hertz is called audible range for the normal human ear. Now, ultrasonic sound. Ultrasonic sounds are of frequency higher than 20,000 hertz, and these are known as ultrasonic sounds. We cannot hear ultrasonic sounds, but animals like monkey, dogs, bats, leopard, deer, they can hear ultrasonic sounds. Audible range for dogs is up to 50,000 hertz and bats 100,000 hertz. Okay, use of ultrasonics by bats. At night, bats easily move without colliding with any object. Why? Because they can produce ultrasonic sound as they fly, and when this ultrasonic sound comes back after reflection from any object or obstacle in their way, they hear it and thus they detect the presence of the object and they change their path. Means the ultrasonic sounds that are produced by bat, when those sounds after reflection comes back towards the bat, they detect the presence of the object by those reflected ultrasonic sounds. Okay. Infrasonics or subsonic sound. Sounds of frequency lower than 20 hertz are called infrasonics. Okay, the sounds of frequency lower than 20 hertz are called infrasonic sounds or subsonic sound, and we cannot hear these infrasonic sounds. For example, pendulum of a clock makes one vibration in 2 seconds. The frequency of the sound produced due to its vibration is 0.5 hertz, and it is infrasonic sound, and hence we cannot hear the sound of the pendulum of a clock. Now the frequency range of different sounds are below 20 hertz, infrasonic or subsonics, 20 hertz to 20,000 hertz audible range for human ears, and above 20,000 hertz ultrasonics. Okay, now you have to read this also. Do you know characteristics of sound? A sound wave is characterized by its amplitude and frequency, and depending upon the amplitude and frequency of a sound wave, we have the following two characteristics of sound. First one is loudness and the second is pitch. Now loudness. Loudness of a sound depends upon the amplitude of the vibrations of the vibrating body producing sound. Means loudness depends upon the amplitude of the vibrations produced by a sound. Greater the amplitude of the vibrations, louder sound is produced. Means if the amplitude of the amplitude is greater, louder sound is produced. As you can see here in this figure, amplitude of wave B is greater than the amplitude of wave A. Therefore, the sound produced by this is more than louder than the wave B. Okay, if you gently pluck the string of a sitar or guitar, a soft sound is heard. But if you plug the string hard, it moves more from its rest position, that is, the amplitude of vibration increases and loud sound is heard. Okay, similarly, if you strike the drum gently, a feeble sound is heard. Means if you beat the drum, if you strike the drum gently, a weak sound is heard. But if you strike it hard, a loud sound is heard. Thus, loudness is a characteristic of sound which distinguishes a loud sound from a feeble sound. Means by the this characteristic loudness, a loud sound can be differentiated by a feeble sound. The loudness of sound also depends upon the area of the vibrating body. For example, if you take two drums, a big one and the other is small, and if you beat both of them, this big drum has greater area, therefore loud sound is produced as compared to this small drum because it has small area. Okay, so therefore greater the area of the vibrating body, louder sound is produced. Okay, therefore the drum that is big produces a loud sound as compared to the small drum. Now, pitch. The pitch of sound depends on its frequency, that is number of vibrations produced per second by the body, because frequency is number of vibrations produced per second. A sound of high frequency is said to have a higher pitch, while a sound of low frequency said to have a low pitch. For example, you can see here in this figure two waves A and B, okay, in which wave B is of higher frequency than that of B, because the vibrations produced per second is more in this wave B as compared to wave A. So the pitch of wave B is higher than that of wave A. Higher the pitch, shriller is the sound, but if the pitch is low, the sound is flat or grave. The voice of a girl is shriller than that of the boy, because the voice of the girl is of a high pitch as compared to the boy. The voice of a child is shriller than that of an adult. Okay, so pitch is a characteristic of sound which distinguishes a shrill sound from a flat sound. And for this, you can see this activity. Here you can see a test tube with a little water in it. This test tube A with little water in it. Now, if you blow air in the tube by placing your lip on the mouth of this test tube, you will hear a flat sound, that is sound of low pitch. Now add more water in the test tube, as you can see here in this figure B, C and D. Okay, you can see here, so that the length of the vibrating air column above the water level decreases. You can see here, here the vibrating air column is more as compared to test tube B. Here it becomes less, and here the least, because here the length of the vibrating air column decreases, and as the length increases then no more number of vibrations are produced, therefore high frequencies sound is produced, and higher is the frequency, higher is the pitch, and more shriller is the sound. Okay, so this is all for today. You have to read this lesson up to here, and further explanation we will continue in our next video. Thank you.